Now we will see how we can find the distance between parallel lines. You can see over here L and M are parallel lines. How do we find the exact distance between them? So you need to consider any of this line. It's up to you. I will choose this line M. Okay. You need to find the perpendicular distance from this line, to any of the point in the other line. It must be perpendicular. So now what it means is you do not need to find 2 points of the lines and something like that. No. First, if you choose this line M, use this particular line, find a perpendicular line to this line, okay? So using any point, you can find a perpendicular line. Then you need to find the intersecting point with this line and then find the distance between these 2 points. Anyway, it sounds hard, it sounds confusing to be honest. We will do a problem, you'll understand how to do it. So before we go ahead, let's see this. Two lines equidistant from third. In a plane, if two lines are equidistant from a third line, that means if the distance between these two lines, say, is 2 and 2 over here as well, then those two lines are parallel to each other. Okay, why? Because they're all in the same distance apart, so then they are parallel. Now over here, that is what it means. Now these are the two lines, right? Over here, if the W is equidistant from X and V is equidistant from X over here, if the distance is same, then they are parallel. So that is the thing. Now let us see this problem. Distance between parallel lines. Find the distance between the parallel lines R and T. Over here, the diagram is not accurate, but since the slopes are negative, we can consider this to be the diagram. Let's consider this is R and this is T. With the equations, y equals minus 3x minus 5 and y equals minus 3x plus 6. Now look over here. If they are parallel lines, the slopes must be same and the intercepts must be different. Yes, absolutely. In these two equations, you can see the slope is minus 3 of both the parallel lines and the y-intercept is different. Yes, they are parallel. So now we need to find the distance between them. So now what we need to do is find the equation of the perpendicular line. We need to know the perpendicular line now. So we need a perpendicular line, say anything, Q or anything. So then we can find the distance between the parallel lines. Now over here, we can consider any one equation. Now this is important because now you will consider any one of the equation. Then if we consider this, say the line R, then we won't use the intersecting point for this line. We have to use the other equation later on. So for now, time being, we will just consider the first equation over here. I'll just double check. Yes, the first equation is considered. So now what we will do is find the slope of the perpendicular line for this. We know the slope of perpendicular lines will be -1 when you product of the slopes of the perpendicular line are -1. So I'm considering this line and I will find a perpendicular line for this particular equation or this line equation. So now I have this line, so I will find the perpendicular from this, originating from this. So what do we do? First find the slope of the perpendicular line. Multiply -3 times the slope of the perpendicular line equals -1. Negative negative cancels and it will be 1 by 3. Okay, that is the slope of the perpendicular line. Now you need to consider any one of the equations. So we have considered the first equation. And now let us find any coordinate. The easiest of all coordinate is assume x to be 0. Assume this x to be 0. Okay. What is the y value when x is 0? Put over here 0. What is the y value? -3 minus 0, it's all 0, gone. What is the y value remaining? -5. So why it is easy to take x is equal to 0? Because whenever you want to find the coordinates of this at x is equal to 0, what is the coordinate? Remove this term because 0 makes it 0, right? Answer is 6 in this case. In this it is -5. Okay. Now we are just focusing on the first equation. X is 0 and y is minus 5. Now use these points. So now basically what happens is I will consider this line, okay? And this particular point is the point where I have my perpendicular line. So these points is shared by the perpendicular line as well. So I will use these particular points to find the equation for the perpendicular line. Now how do we find the y-intercept? Use these points over here. X is 0, y is minus 5. Solve it. You will get the b value to be minus 5. And now I can write the equation of the perpendicular line. So the perpendicular line equation is y equals, the slope is 1 by 3x minus 5. I hope this much is clear. Now all we know is there is a perpendicular line having this particular equation. Okay, and to find the perpendicular line we have used this particular equation. So we know this much now. This, imagine this is the line, parallel line, one of the parallel line. We now know the perpendicular line. We know the equation of this and this. We know there is a other parallel line as well. Now the important thing is distance. Now this equation is used to originate the perpendicular line. Now you need to find the intersection. See the intersection between this perpendicular line and the other parallel line. So find the intersection between this perpendicular and this parallel. It is similar to what we have done in the previous video, the previous problem. Let's see now how we do that. We need to find, okay, I will tell you what this exactly means. Now we had used this particular equation already, right? So leave that. So other parallel line is considered to find the intersection point, because now this much is there. Now to find the intersection point, we need the equation of this and the perpendicular line and solve it, and you will get the intersection over here. So use the other line. See, y is equal to minus 3x plus 6. This step was done in the last video as well, last type of problem. So use this particular line, rearrange it and write it as 3xy plus x plus y equals c. 3x plus y, this 3 minus 3 becomes plus 3x plus y equals 6. What about the other one, y? This equation. This is the perpendicular line equation. Now, minus 1 by 3x plus y equals negative 5. So now all you need to do is go to mode 5 and 1 and now substitute them. 3, 1, 6. And sorry, I have not typed the other equation, so obviously it will be infinite. Okay, over here, minus 1 divided by 3, 1 and minus 5. So what are the answers? We are getting 3.3 and 3.9. So these are the intersecting points. I will tell again, we had used this particular equation as the base and we formed a perpendicular line. So we used the details of this equation to find the perpendicular line equation. So we found the perpendicular line equation. Now there is one more parallel line. See, this and this are parallel. So I'll write P over here. Sorry, PA parallel, PA parallel. So now we know these both, but we already used this particular equation, PA1. This is better, and this is PA2. So we used PA1 to find the equation of this perpendicular line. So we use that to find the equation of the perpendicular line. So now we use PA2 to find the intersecting point over here, this any point, okay? Because the distance between parallel lines is the perpendicular from any one of the parallel line and the point of another line, point, okay? So now how do we find this point is we equate the equations of this PA2 and perpendicular line PER. Okay, so that is what we have done. We are done equating these both. So make in terms of x plus y equals c. Get in terms of this, say x plus y equals c. Over here also x plus y equals c for the perpendicular line. And when we solve, we get the intersecting point. So now we got this intersecting point. Okay. Do you remember which point over here was considered? We had considered one point. I had told take x is 0 and the y was minus 5. So we know over here the perpendicular line touches the initial line at 0 comma minus 5. And what about this? We just now solved now. It is 3.3, sorry. 3.3 comma minus 3.9. So now we know both the intersecting point. I'll just show you where is this 0.0 comma minus 5. See over here. We had considered this, right? That is very crucial for now. Because now we know the two intersecting points. If we find the distance between 0 comma minus 5 and 3 comma 3, we will get the perpendicular distance. Let us do it now. The intersecting points, that is 0 comma minus 5 and 3.3 comma 3.3 and minus 3.9. Find the distance over here, x1 y1 x2 y2. Find this distance between them, and over here you will get the answer 3.48 units. So the distance between the parallel lines of these two equations is, 3.48 units. That is the answer for this question. So that is how we solve this particular lesson. Few things to remember: equations of parallel or perpendicular lines, solving the equations using calculator to find the intersecting point, and the distance formula. And then you can easily solve it. So we have come to the end of this lesson. Please write your doubts or any queries in the comment section and I will get back to you as soon as possible. Thank you very much.